Hi students, welcome to our physics class. In today's class, we are going to learn progressive waves and its characteristics. Progressive wave, otherwise called as traveling waves. Okay, so what is meant by progressive wave? If a wave that propagates in a medium is continuous, then it is known as progressive wave or traveling wave. A wave which is traveling continuously in a medium is known as traveling wave or a progressive wave. It progresses. So, what is progressive wave? If a wave that propagates in a medium is continuous, then it is known as progressive wave or traveling wave. Now, the characteristics of progressive waves. What are the characteristics? First point, particles in the medium vibrate about their mean position with the same amplitude. Particles in the medium vibrate about their mean position with the same amplitude. So listen, this is the progressive wave. A wave propagates in a medium. This point is known as mean position. Mean position. So the particles in this medium vibrate about their mean position with the same amplitude. This is the amplitude. The maximum displacement is known as the amplitude. This is the amplitude. This is the amplitude. So it vibrates about mean position with the same amplitude is known as progressive waves. The next point is the phase of every particle ranges from 0 to 2 pi. The phase of every particle ranges from 0 to 2 pi. That means, consider a wave. Okay, here the phase, the position can be denoted as this is 0 phase, this is pi by 2, this is pi, this is 3 pi by 2 and this is 2 pi. So, every particle ranges from the phase 0 to 2 pi. Understand? The next point is, no particle remains at rest permanently. Since it is a progressive wave, it progresses, it travels, so no particles remain at rest permanently. During wave propagation, particles come to rest position only twice at the extreme position. When the wave propagates at the extreme position, suppose this is the wave, so these two ends are called extreme position. Okay, so when it propagates, the particles come to rest position only twice at the extreme points. Next point, transverse progressive waves are characterized by crest and troughs. Transverse progressive waves are characterized by crest and troughs, whereas longitudinal progressive waves are characterized by compressions and rarefactions. This point already we have discussed. Next point, when the particle pass through the mean position, they always move with the same maximum velocity. When the particle pass through the mean position, they always move with the same maximum velocity. The next point, the displacement, velocity and acceleration of particles separated from each other by n lambda are the same, where n is an integer and lambda is the wavelength. Displacement, velocity and acceleration of particles separated from each other by n lambda, 1 lambda, 2 lambda, 3 lambda and so on. So each particles are separated, the particles are separated from each other by n lambda. So where n is an integer and lambda is the wavelength. So these are the characteristics of progressive waves. The next concept is equation of a plane progressive wave. Here a wave is represented at time t equal to 0. This is the position of the wave. This is the particle position. And after the time t, this is 0 time, after the time t, it travels some distance. Let us say the distance is v into t because the wave travels with a velocity v. So we can write vt distance it travels and the position is shifted here. So after a time t, this is the position of the progressive wave. So in order to write the equation of a progressive wave, we have to use the mathematical differential equation. That is, the function we can written as y of x comma t is a displacement. The position is equal to f of x prime is equal to f of x minus vt. That means at time t equal to 0 the position is there. After the time t it travels with a distance vt. So we can write the position. If the wave is traveling towards right, we can write the function as f equal to x minus vt. Suppose if the wave moves towards the left, we can write y equal to f of x plus vt. So either we can use y equal to f of x plus vt or we can use y equal to f of x minus vt. And this will satisfy the differential equation as dou square y by dou x square equal to 1 by v square into dou square y by dou t square. Actually this term dou y by dou x is the partial derivative. Okay, but if the function represents a wave, then it must satisfy the differential equation. That means we can write the differential equation, the total derivative as d square y by dt square dx square is equal to 1 by v square and d square y by dt square. This is for only one dimension. X direction only, so we can write one dimension. So this is the equation of a plane progressive wave. Now let's discuss graphical representation of the wave. Graphical representation of the wave. There are two forms of wave variation. One is space variation graph, or we can say spatial variation graph. The next one is time variation graph or temporal variation graph. Okay, space variation graph and time variation graph. What space variation graph says? By keeping the time fixed, the change in displacement with respect to x is plotted. Okay, by keeping the time fixed, the change in displacement with respect to x is plotted. This graph is known as space variation graph. So here we are using the graph as sinusoidal graph. Okay, sinusoidal graph, that means sine wave. Here we are keeping the time is fixed. Now the position, the displacement with respect to x is plotted here. Okay, the displacement with respect to x is plotted. The displacement is actually y with respect to x is plotted here. Let us consider this is the wavelength, the length. Distance between these two positions is wavelength. Okay, suppose this is a particular distance travelled x, then after it may comes to this position. So distance travelled by the particle is x plus lambda, because distance between these two is lambda. Either distance between these two or distance between these two. So we can say this is the initial position of the particle or the first considering position. Then after it comes here, it travels with the distance as lambda. So we can mark the position as x plus lambda. So we can write the equation as, if y equal to x, we can write y equal to displacement equation is y is equal to a sine kx. A sine kx, where k is known as the wave number. And if the displacement is y equal to x plus lambda, we can write y equal to a sine k, and instead of x we have to put x plus lambda. So we can write a sine kx plus k lambda. K into x plus k into lambda. Now listen here. The sine function actually has the period 0 to 2 pi, isn't it? 0 to 2 pi. A sine function is a periodic function with a period 2 pi. So when we are writing y value, y is equal to a sine kx plus 2 pi. The distance we can write written as 2 pi, kx plus 2 pi. That is equal to a sine kx, because sine 2 pi value is equal to 0. So we will be getting y is equal to a sine kx. Understand? A sine kx. Now when we are comparing the equations, the previous equation with this, that is y is equal to a sine kx plus k lambda, and y is equal to a sine kx plus 2 pi. So kx plus k lambda equal to kx plus 2 pi, kx get cancelled, k lambda is equal to 2 pi, or else k is equal to 2 pi by lambda. Unit is radian meter raised to minus 1. 2 pi is the radian, lambda is the wavelength, so unit of wavelength is meter. So radian meter raised to minus 1. So what is k? K is known as the wave number. That means number of waves, number of wavelengths present in 2 pi radians. Number of wavelengths present in 2 pi radian, that is k equal to 2 pi by lambda. From this we can write lambda is equal to 2 pi by k in meter. Lambda is equal to 2 pi by k in meter. So for the fixed time 0 second means we can write y of x comma t is x comma 0 is equal to y of x plus lambda comma 0. After time t, y of x comma t is equal to y of x plus lambda comma t. This also we can. So this is about space variation graph. Okay, keeping the time fixed and you are plotting the displacement with respect to x. The next one, time variation graph. Time variation graph. So what is meant by time variation graph? By keeping the position fixed, the change in displacement with respect to time is plotted. Okay, by keeping the position fixed, the change in displacement with respect to time is plotted. So here the x-axis we are considering the time, and this is the displacement. Okay, so here this is the time variation graph. So as per the time increases, the position is plotted. So here also we can write the equation of displacement as y is equal to a sine kx, or else we can write y is equal to a sine omega t. So what is meant by omega? Angular frequency. Angular frequency. This means wave oscillates or number of cycles per second. Angular frequency means number of cycles per second. So here the phase position is actually for a wave it is 2 pi, isn't it? So we can write omega in terms of 2 pi. That is t is equal to 2 pi by omega. Time is equal to distance by velocity. Distance is here 2 pi radian. Velocity is angular velocity. So omega is equal to what? 2 pi by t. And also we can add omega is equal to 2 pi into f. 2 pi into f. F is equal to 1 by t. The inverse of time is known as the frequency. Okay, or t is equal to 1 by f in seconds. Understand? So here we can write the velocity also, or the speed. V is equal to lambda by t. That means the distance travelled by the wave per second is known as velocity. Distance travelled by time is known as velocity. Here for a wave, distance travelled by the wave, that is lambda per second, is taken as t, that is equal to lambda by t. So this can be written as V is equal to lambda into f, because 1 by t is f. So V equal to lambda f in meter per second. So this is known as particle velocity, or we can say wave velocity. Understand? So far we have discussed about progressive wave, characteristics of progressive wave, equation of progressive wave, and graphical representation of the waves. Understand? Now one more topic, particle velocity and wave velocity. Actually we have obtained the relation. Anyway, we can discuss how it arrives. Particle velocity and wave velocity. So particle velocity, when a particle is in motion, the rate of change of displacement at any instant of time is defined as the velocity of the particle at that instant of time, isn't it? Rate of change of displacement. So Vp is equal to what? Dy by dt meter per second. So here we can substitute the value of y, the displacement. Y of x comma t is equal to a sin kx minus omega t. This is the displacement equation for a sine wave, sinusoidal wave. A sin kx minus omega t, where a is the amplitude, k is the wave number, and omega is the angular frequency. So change in displacement, rate of change of displacement is velocity. So we have to differentiate this equation dy by dt with respect to time. So when we are differentiating, a constant and sin kx minus omega t is nothing but differentiation of sin theta is cos theta. So we can write cos kx minus omega t into this term represents the time dependent. Okay, so this also we have to differentiate again. We will be getting minus omega into 1. So that I am writing here minus omega. So what is that? Dy by dt is equal to minus omega a into cos kx minus omega t. So this is the velocity. Okay. Similarly, we can define the velocity for a progressive wave also. Okay, so progressive wave we have to consider the wave is traveling from one end to other end. That means moving towards right. So we can take the equation y is equal to, that means y is equal to y of x comma t is equal to a sin kx minus omega t. Okay, after the next time, let us say t prime is taken as t plus delta t, after the initial time plus some more time, and the position of the particle may shifted by x prime, that is equal to x plus delta x. Okay, now the displacement at any instant can be written as y is equal to y of x prime comma t prime. That means y of x plus delta x comma t plus delta t. Isn't it? Now we can substitute y equal to a sin kx minus omega t. Y is equal to a sin kx. So instead of kx we can write k into x plus delta x minus omega t. Instead of t we can write omega into t plus delta t. Okay, a sin k into x plus delta x minus omega into t plus delta t. So here the shape of the wave remains same, isn't it? Shape of the, when the progressive wave is considered, the amplitude is maintained as constant. So we can say shape is same, and also the phase of the wave also remains constant. Phase is constant, shape is constant. So we can write the equation y of x dash comma t dash is equal to y of x comma t. Okay, y of x dash comma t dash is equal to y of x comma t, because shape is constant as well as the phase is also remains constant. Now we can substitute the value, that is x dash comma t dash is nothing but a sin k into x plus delta x minus omega into t plus delta t is equal to a sin kx minus omega t. Now a sin we can get cancelled. So the remaining terms are, what is that? K into x plus delta x minus omega into t plus delta t is equal to kx minus omega t, that is equal to constant. So when we simplify this, kx plus k into delta x minus omega t Listen, particle velocity and wave velocity we are discussing. So we have taken the velocity formula is rate of change of displacement, that is y equal to a sin kx minus omega t. So if you differentiate, you will be getting dy by dt equal to minus omega a cos kx minus omega t. Now after the time t, the position will be changed, so we can write t dash is equal to t plus delta t and x dash is equal to x plus delta x. So y of x comma t can be written as x dash comma t dash, that is y of x plus delta x comma t plus delta t. Just substitute the value of x plus delta x and t plus delta t in the displacement equation, and we will get y equal to a sin k into x plus delta x minus omega and t plus delta t. Since the shape is constant, phase is constant, we can equate the two displacement equation, y of x dash comma t dash is equal to y of x comma t. So after simplifying this, we will be getting delta x by delta t is equal to omega by k. Delta x by delta t is equal to omega by k, that is equal to velocity, wave velocity or phase velocity. Also we can have omega is equal to 2 pi into f, isn't it? Or else we can write 2 pi by t. And we know that k is equal to 2 pi by lambda, number of waves in 2 pi radians, isn't it? So when we do this, omega by k is equal to, that is 2 pi by t by 2 pi by lambda. What we will be getting? Lambda by t. So omega by k is equal to lambda into f. 1 by t is f, that is equal to v. So the relation connecting velocity, frequency and wavelength is v is equal to lambda f. Understand? So this is about wave velocity. Okay students, today's portion, learn well characteristics of progressive waves and mainly the concept of equation and graphical representation of the wave. Then you should know the relation between wavelength, velocity and frequency. Thank you students.